So then the finite element model, we're going to let u be approximately equal to u of h, which is a function of x and y, and that's going to be equal to n j u j. And del u I is going to be equal to n I. I'm going to try to get in the habit of, whenever I'm talking about finite element, shape functions, right? So this is like the jth shape function, right? This is the jth node in the discretization. Whenever I'm talking about things associated with nodes and shape functions, I'm going to try to use capital letters, so it's a capital I and a capital J. And that's opposed to the lowercase ij that we use in additional notation to represent components, like of a stress tensor. Right? Doesn't really matter that much when you're talking about scalar fields, but next time we'll talk about vector fields, and we may want to use the lowercase ij to represent tensor components, and then we don't want to confuse that with element components. Or shape functions in node. Okay, so if we plug that in, we will have all this should be under an integral sign. And then I'm going to put the constant uj outside the integral, right? So those are the constant nodal values, unknown nodal values that we're solving for, but they're constant with respect to x. So we'll move them x and y. So we'll move them outside. And then we'll also have and so this is our stiffness matrix. Okay, and then we'll call this Fi. We'll call this Qi. And so then our final element equations that we're solving will be Kij Uj equals to Fi plus Qi.
Go back and put the A nouns, it is N, I, and J.
N-I-N-J, yes. So yeah, in vector notation, this would be K, where K is a matrix or tensor, times a vector of unknown coefficients U is equal to F plus Q. And we might choose to write our stiffness matrix a little bit different. We could write that K, again in matrix notation, is B transpose C B dx dy. F is what it was, but in vector notation. Where B B is equal to D in transpose. So we're applying our D operator to the element shape function matrix. So that equals something that looks like, well, in this problem, N1 comma X, N2 comma X, dot, 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 N comma X, N1